Welcome to Cranky Calculus here. We're going to talk about optimization, but we're going to focus today mostly on calculator problems. And the big thing for today is using candidates test with the calculator and what the expectations are on the AP exam and how you would be graded on this. So make sure that you like and subscribe for more information like this, and let's get rocking and rolling here into what optimization is. I've done a video on optimization already, so you probably have already seen this. But this is the steps of how to go through optimization and what it is. Optimization is just trying to find the maximum or minimum value of some type of quantity, which is why we have to use candidates test. So let's just go ahead and get rocking and rolling right down here to the first of our calculator problems. So we're going to focus on our first problem right here, which is a man launches a boat from point A on a bank of a straight river, 4 kilometers wide, and wants to reach point B 10 kilometers downstream on the opposite bank as quickly as possible. He could row his boat directly across the river to point C and then run to B, or he could row directly to B and row to some point D between C and B where they run to B. So they can row 5 kilometers per hour and run 8 kilometers per hour. Where should he land to reach B as soon as possible? So let's just quickly draw a picture, which is actually our first thing that we always need to do here. And I'm actually going to draw a little bit of a river. So there's my river. Let's deal with it. So we're going to start right here at point A, and we're trying to get over here to point B. We do know that this river is 4 kilometers wide, so 4 km. We do know that from A to B is going to be 10 kilometers. So from there to there is going to be 10 kilometers. So what we're going to do here is got a couple options. We can either row the entire time, which is going to go from here to here. We can go directly across to point C from here to here, which we know that what these distances are. We can find the A to B one by using the Pythagorean theorem. Or we can land somewhere in the middle at point D and then row the rest of the way. So for what we're going to do here is we're going to assume that we land at D, and maybe D has a value of 0, maybe D has a value of 10 based on where we are located to B. So I think this is just easiest to just assume we're going to land at D, and we'll kind of look at our candidates from there. So real quickly, if we're going to go from C to D here, let's call that X, okay? And then we know from A to C that is 4, and then across the way from A to D, that A to D value is going to be the square root of X squared plus 4 squared, which is going to be 16. That's going to be just A squared plus B squared equals C squared. So that gives us all the values. So what we want to do here is we have to figure out what the heck we're trying to minimize here. So we have rates, we have distance, we have time, and we're actually trying to minimize how quickly we can get somewhere. We're trying to minimize time. So we need to write this as a function of time. So in case you didn't know, rate is always distance over time. So if I solve for t, time is going to be distance over rate. So our time for rowing, our rowing time is going to be, the distance is x squared plus 16, which is the hypotenuse right there, all over the rate, which for rowing, we have right above us, is 5. Time for running is going to be, well, the distance from B to D. The whole thing right here is x. This would be from D to B would be 10 minus x. So we're going to get 10 minus x in the numerator all over. Our rate here for running is 8, as it states in the problem. So we can write our time function as adding those together. How much are we going to row? How much are we going to run? So there's going to be x squared plus 16 all over 5 plus that square root, which should be just 10. 10 minus x all over 8. And what we want to do here is take the derivative of this, set equal to 0, and see what we get here and compare this with different candidates. We're going to do this all in the calculator here. So we're going to do t prime of x is equal to 0. We're going to find those values. I'm going to get to that part in just a second here. And then I'm going to make a candidates test chart here. So I do this because my lowest x value I can possibly have is 0. And that means that I am actually landing all the way across from A to C. My greatest is actually going to be 10. I can have x equal 10 where I am not running at all. And what I would do is I would substitute this into my t of x value to get those values. So I'm going to do all of this here in the calculator here. Make sure that you have your calculator fired up. If you can use Desmos, that makes it much easier, but I'm going to go ahead and show you out of a TI-84 because most schools test you on that. So I want you to know how to do this on a TI-84 calculator. Moving over onto the calculator part right here, make sure we type in our function to y1. I already have that done for us. We don't even need to graph that, but I do want to have it there. What I'm going to do here is pay attention because my students sometimes don't pay attention to everything. I'm going to go ahead and move my little cursor over to this equal sign. I'm going to hit enter so I don't waste time graphing it. What I wanted to do though is I do want to graph the derivative. In order to graph the derivative, you're going to hit I hit alpha F2 to pull up this table of everything. That's just what I like. Some people like to use the math button. But anyway, choice 3 is the derivative. We're going to do the derivative with respect to x. And then I'm going to do alpha F4, which pulls up all the y values. You can also go through vars if you really wanted to. I think it's quicker this way. And we're going to let x equals x. And this is going to graph the derivative of every single pixel. Now, I only care about when we equal 0 here. So I'm going to real quickly go to the window and play with this a little bit. I know my window goes from 0 to 10. That's just going to help me with some of my values. And for my y minimum, I'm just going to go from -1 to 1 because I only care about when this crosses the x-axis. So now, it'll graph kind of slow. On my program, a little bit faster, but you can clearly see here that this does cross right here. To find that value, you're going to hit second calc, and then you're going to go ahead and do 0 to find the 0 value. Down here, we'll tell you where your 0 value is. We know that we're negative to the left, so I'm just going to scroll over it. Actually, if you hit second over, it goes a lot faster. It's probably easier to do with your thumbs rather than a mouse. But you can tell right here for our y values, we're actually below the x-axis, so we're good to go. And then I'm going to hit this, probably a little quicker, we can just press this over. We have positive y values, so we know that we're on the other side of the x-axis. It just says guess, just press enter one more time. And there is going to be our critical point that we have, and that's going to be where the derivative is equal to 0. What I want to do is I want to save this though. You hit second quit, and then you press X, enter. It's just going to plug that right back into that calculator for you. That way we have access to it. So since I'm going to do candidates test, I want to be able to find out what all these values are. So I'm going to go ahead and hit second or alpha F4, go to Y1. I want to know the value at 0. That's part of the candidates test. I want to know the value at my X value. This will give us the time there. And then I want to know the same thing for the value at 10, because I got to include my endpoints here to make sure we know exactly what we're doing. Okay, so for the first one right there, that's just 41 over 20. That is actually going to be a little bit over 2. We got 1.874 for the X, and then for the 10 we have 2.1, again a little bit over 2. So if I'm looking for the smallest time, that's actually going to be right here. So I'm going to go from this part of the calculator, I'm going to plug everything in. I'm going to go back to my other screen here. I'm going to throw everything onto the notes, that way you can see exactly what's expected of you. So all I did here is, you can see it in blue, I just typed in where the derivative was equaled 0, and then I did the table based on those values from my calculator. So everything's done right here. This is all you need to show for a calculator problem. And then all I have left is to answer our question here. So where should he land to reach point B as soon as possible? So he should reach, and if I have X, X is the distance down the river, so we're just looking at 3.202 kilometers down the river. And that will wrap up this very first question for us. Okay, we got another, this is more of a common question than the other one. We got another good problem here with candidates test and optimization. Find the area of the largest rectangle that can be inscribed inside the function of 4 cosine x in the interval from negative pi over 2 to pi over 2. So I'm going to quickly sketch this for you. See what this looks like. If hopefully you know what the cosine graph looks like. Cosine looks something like this. All right, and what we want to do here is, it's not the best graph I've ever drawn, but whatever. And we're going to go from, this is negative pi over 2. This is right here, pi over 2. And what I want to do here is I want to find the largest rectangle that I can make inside of here. Now, I don't know what these are, but I do know this is the point x comma y. This is the point negative x comma y. This is the point down here, x comma 0. And you can obviously tell that on the left-hand side it's going to be negative x comma 0. I just can't fit it on in there. So we want to find the area of this rectangle. So to find the area of this rectangle is going to be not x times y, that would be just be in the first quadrant. It's going to be the whole thing. So if I'm looking at the whole thing, I actually have 2x's times y. Because the 2x's, the positive x side and the negative x side, give me 2x's times y. So what we need to do here is I want to write this as a function of x. Now, we can substitute out this y for this cosine of x right there. So the area is going to be 2x times 4 cosine of x, which I can rewrite as 8x cosine of x. So what we want to do here, and we have access to the calculator, a lot of this stuff we can do by hand, not all of it, but what we want to do here is we do want to find the derivative and set this equal to 0. So the derivative of a is equal to 0 at, and then we're going to do kind of the same thing here, where we're going to be picking out some values, and let's just go right to the calculator and see what we're doing here. So I went ahead and typed this in already to the calculator. I have the area function on the top, and I have the derivative on the bottom there. I changed my window already. So the smallest, think about it this way for the rectangle, the smallest x you can possibly have is 0, and the largest possible x you can have, because we're between negative pi over 2 and pi over 2, is pi over 2. So that's why my x maxes are there. I only care about when I cross the x-axis, so that's why my y min and y max are so small. And we're going to go ahead and get this right here. So I'm going to hit second trace, get the 0 there, and then we're looking at these y values. So we're currently positive, so I'll just press enter. I don't know where that thing is. And then we're negative over here, press enter, and then so we're going to get 0 right there. I'm going to go back to home, hit X, and then we can get those values right there. Okay, so now what we're going to be looking at is we're looking at our candidates test again, and I mentioned how our smallest value here is going to be 0. So if x is 0, what is our area? And again, if you notice, I am pulling from the y1, which I did not graph. I don't need to graph it. I just need to refer back to it so it's easiest. Oh, I just noticed the screen isn't all the way over there, but y of 0 is 0. You can just test that in yourself. I'm going to actually press up and then scroll over. I think it's faster that way. And this one's going to be a 4.488. And then I'll do the same thing. I'll just scroll up here, grab that, and this is going to be pi over 2. And that's going to give me an answer of, you can't see it on there, but it's also going to be 0, which makes sense because our y height will be 0. So let's go ahead and take all this stuff and go ahead and apply it into our notes. So coming out of this problem, I found that a prime is equal to 0 at that point 806. Now the reason I put ... there afterwards is because I'm letting you know that I'm actually going to type in the entire answer, not just a portion of it, especially when you do candidates tests. We don't want to plug in rounded answers to get more rounded answers. We want to plug in the exact values if we can. I made my sign chart based on what we did in the calculator there, and you can clearly see that we're going to have a maximum, find the area of the largest rectangle. So our maximum is, max area is 4.488. We don't really have units here, so it's just 4.488 units squared or whatever. I'll just put 4.488. That's the largest area of any rectangle we can draw inside. That is inscribed inside that 4 cosine of x. So that's going to wrap it up. This is all you need, by the way. You don't need to show every little step. This is what you need to do. We're not talking calculator either. We are giving the exact values. We're justifying through calculus here. So don't forget to like and subscribe to see more videos like this.